Hey folks, welcome back. Today we're going to be talking about inverse functions again. Now, the emphasis we're going to be looking for is to verify if two functions are inverses of each other. Well, and the way we're going to use it is composition of functions. Don't worry, not incredibly difficult and not incredibly long. So, first thing I need to remind you of is, guess what? We have a quiz next Tuesday. Expect that you should be studying for that. We'll spend some time in class going over people's questions, but I'm going to push that out on Tuesday during class. And to help you to study, I'm going to give you a worksheet. If you go onto the weekly preview, you will find that worksheet and the key to that worksheet both are posted. So go ahead and work on that this weekend. But for right now, I'm going to talk about inverse functions. And today we're going to be talking about verifying inverses using composition. How do you prove whether or not two functions are actually inverses of each other? How do you go about doing that? Well, don't worry, it's not incredibly complicated. You remember doing the composition of functions. We've got that there. And if you take f of g of x and you come out with an answer of x, and its emphasis and, you take g of f of x, and that comes out to be x, guess what? You've just proved that those two functions are inverses of each other. Let me give you a little for instance here. So here I've got two functions. And I'm going to say, well, let's see what happens when I try and take f of g of x. So f of g of x means that I'm going to take my g of x function, which is x minus 2 over 3, and I'm going to plug that into my f of x function. So let me rewrite my f of x function as being 3 plus 2. And now let's just plug in that g of x function. And we're now going to say, okay, what can I do to simplify it? Well, last time I checked, we've got 3 and 3. Those two things cancel. So I'm now looking at x minus 2 plus 2. And, well, I'm hoping people are going to say, wait a second, plus 2 and minus 2. Those cancel each other out. And I end up with an answer of x. Step 1, done. Well, let's take a look at the second one, where I'm supposed to prove that g of f of x is going to give me something nice also. Again, just to refresh your memory, f of x is 3x plus 2, and now I just substitute that value in for x. Now let's see, what's that going to look like? I'm going to take my 3x plus 2, and I'm going to substitute that into my g of x function right here. So in the place of x, I'm putting the 3x plus 2. That's going to leave me with minus 2 over 3. And at this point, I'm going to say, wait a second, plus 2 minus 2 gets me 0. And that's also going to get me 3x over 3. Oh, I can cancel my 3's, and I'm looking at x. Guess what? Once again, I've just proved the second required thing, and we're done. I can now confirm that these two functions are inverses of each other. On the other hand, let's try another case and see if this one works out. Okay, I've got two functions here, 3 and 4. Looks like they have something to do with each other. Let's see how this works. So once again, I'm going to say f of g of x right here. So that's going to be f of quantity x plus 3 over 4. And so let's see, what is my f of function? Oh yeah, my f of function is 3 times something minus 4. And now I'm going to substitute that in the place of my x. And I'm now going to be saying, ouch, I'm looking at 3x plus 9 over 4 minus 4. Is that ever going to be equal to x? Heck no. So therefore, I can say right away, these two things are not inverses of each other. And guess what? That's it. That's how you prove two functions are inverses of each other. So we're done for the day. I'm going to say go ahead and get to work on your review, and I'll look forward to seeing you guys later on.